couple of announcements to make. One is an award presentation, and this is our annual Shreve Award for Outstanding Undergraduate Teaching. The Shreve Award, that previously used to be called the Shreve Prize for Chemical Processing, was established in 1960 by Professor R. Norris and Eleanor Shreve, his wife, former head of the school, and a well-known author of a book which was named in 2008 as one of the 30 groundbreaking books in chemical engineering in the first 100 years of AICHE. There were 3 of these books, by the way, written by, co-authored by Purdue professors. 3 out of 30, 10% were written by them. And that's Shreve, this book was one of them, and he established this prize for chemical processing. And then in 1974, this particular prize, called the Shreve Prize, was made into the Shreve Prize for Undergraduate Teaching, Outstanding Undergraduate Teaching in the School of Chemical Engineering. And we have a number of outstanding teachers here, and I'm really very, very pleased to say that this year's winner, which in fact is actually from 2012, which I'm talking a little bit ahead in advance, is Professor Neil House. So I want to, let's say, congratulate him first, and I'll say to you. Professor House received his bachelor's degree from Georgia Tech and the PhD from the University of Houston, working in two-phase flow problems with the pioneer of the field, Professor Abe Duckler. He joined Purdue University in 1969 and has been here ever since and been a mainstay of the undergraduate teaching program. He is one of the most outstanding teachers, not only of this school, but of the college and the university. In fact, he has received the College Outstanding Teacher Award, as well as the University's Outstanding Teacher Award, also previously. And this particular Shreve Prize that he is receiving this year in school is the 5th one that he has received. In fact, because of him and another professor sitting here, Professor Delgas, we had to change the rules a few years ago when I joined here, because these guys were just oscillating, receiving the Shreve Prize every other year, because there was a limit that every 2 years you could get it. So there was nobody else who could receive it. So we said, good, we need to change the rules so they cannot win it every time. Then we said it is 4-year gap, so now the others can come inside. And so I'm very pleased to say, he is, by the way, with his 42 years of service, the professor in our school with the longest tenure in the 100-year history of the school. Longest tenure professor in the School of Chemical Engineering, not as an emeritus, but as a regular full-time professor. He did many, many things in the university, including directed the co-op program for which we were just honoring Norm Kilstroff, as you saw him. He was the founder and the director of the universities and the College of Engineering, of course, co-op program, and he did that also for our school. So, Neil, please come. And this award, by the way, comes with a check, which is in the mail, which is for $1,000. And so, congratulations, Neil, and please come. Next, it is really an extraordinary pleasure to announce, and as you may have seen, my message sent only about an hour or so ago, Professor Rakesh Agarwal has been named today by the White House and President Obama as one of the 5 recipients of the country's National Medal of Technology and Innovation. There are only 5 of these people in the whole USA, and this is the highest honor that can be given to a technologist, engineer, and an innovator in the country. These recipients will receive their honor at a White House ceremony later on this year. I'll quote some words that President Obama said in announcing these. Each of these extraordinary scientists, engineers, and inventors is guided by a passion for innovation, a fearlessness as they explore the very frontiers of human knowledge, and the desire to make the world a better place. Their ingenuity inspires us all to reach higher and try harder no matter how difficult the challenges we face. So this is our Professor Agarwal, and as I wrote in my message, he has demonstrated over his career extraordinary creativity and productivity that has really tremendous impact on technologies that are serving society and also improving the lives of others. All his past research, of course, is behind, but what's really very impressive is his current research that goes on for the future, and that is his research in the biofuels area, solar energy, and in energy-efficient separations. Particularly when he joined in 2004, he had said he would really want to make a pretty good break with the previous work he had done, and he came here to start research on solar energy, and now we can see how this has blossomed to such a great extent. This is not the last major national award he will receive. This is just one of many that he will receive. We are so thrilled and delighted that he has been selected to receive the National Technology Award. So great congratulations, Mr. Agarwal. This Friday at 4 p.m. in the Henson Atrium, so please join at that time. Without much further ado, I would like to proceed forward now with announcing and saying a few words about our seminar speaker today. So this is one of our Centennial seminars, and the Centennial year next Friday, just about 8-9 days from now, will be our Centennial celebration right here in this room and the atrium of the building. This is the 8th one, and there have been, so as you remember, there are 4 in industry representing, 4 representing, there are all alumni, of course, 4 representing academia, and 4 representing entrepreneurship and other pursuits. So he is one of the 4 for the industry direction. Just a few words about him. First of all, he graduated from the school in 1977. Now, this turns out to be a very auspicious year, and the class has been very high achieving. In fact, 3 of our 12 Centennial speakers are from the class of 1977. You've already heard Ruby a few weeks ago, and Emily Liggett will be coming down the road in the month of November, and Norm Gilsdorf is the 3rd member of this class of 77. So this was a remarkable year for our school that generated these very highly accomplished graduates. Norm joined UOP immediately upon graduation, and as we have heard, he was a co-op student during this period that he was in. He rose through the ranks with UOP, eventually became the Senior Vice President and General Manager of Process Technology and Equipment Business. Before that, he was in charge, responsible for the UOP's Catalysis, Absorbents, and Specialties business unit. He has been now for a few years the President of Honeywell Process Solutions and has sales of the order of around $4 billion with about 14,000 employees at the end reporting to him. They all don't send him an email, but he has, of course, a number of people that report to him, about 14,000 overall that he's responsible for. He also received, during his career with UOP, he received also an MBA in International Business and Finance from Northwestern University. He has a tremendous amount of global experience, as we will see, and is obvious from the title of his talk. And I think he's a captivating speaker, and he was, as you may recall, some of you, in February 2010, Norm Gilsdorf received the Outstanding Chemical Award and also simultaneously the Distinguished Engineering Alumnus Award of the College of Engineering. So he spoke at the time, and I still remember some of the things that he had mentioned. So, Norm, thank you very much for accepting our invitation, and we look forward to your.
Thank you. Thanks. Well, thank you very much. It's very much an honor to be here and to follow such recognition for you, Professor. Outstanding achievement, a great honor. To me, about as high as you can get. It's a pleasure to be back at Purdue. It's obviously an honor to get to speak to everybody here today, talk to you a little bit about my career, talk to you about what I see going on in the world, how I see it happening, and how I feel many of you can play in shaping that world of the future. I've got some slides that I'll go through, but I want to leave time for question and answer at the end, because I feel that that is obviously, maybe if I haven't hit a point in the presentation, gives you a chance to ask me. As Professor Varma said, I'm president of Honeywell Process Solutions. We're a world leader in developing solutions for industrial sector. We go all the way from making a field instrument like a temperature or pressure instrument to making distributed control systems, all the way to the software that goes all the way up to the ERP level. So I'll talk to you a little bit about my company, not much, mostly about how I have developed my career and how I see the industry and the world evolving. Well, let's start with a little bit about the information age. I don't know if any of you will recognize this. This is a slide rule. I know it's an ancient history. It was at a time when people were just inventing fire. This is actually what I came to Purdue with. And my first year and a half, this was the tool we had to do our calculations. And I know it's probably today hard to believe, but that's what we had. Now, after the first year or so, we started getting the first calculators, and we started getting the first mainframe. I remember my first Texas Instrument, which was the first calculator I could say. In fact, I think I had to be a co-op to be able to afford that. Things evolved. We finally got into the kind of the mainframe era. I don't know if any of you probably will not appreciate, but we used to do our programming for class. We would have to go punch cards on Fortran, and you'd punch all the cards through. And then we had mainframe time, which was usually ideally suited between 2 and 4 a.m. So we would come here downstairs, put the cards in, or go over to the computer lab, and we'd sit there for an hour or two, and they'd give us a massive printout where we realized that we had a typo on card 73, and we would have to go back through the same cycle again. So this was chemical engineering in the dark ages. I'm sharing this with you because just over my lifetime, this is the kind of change we've had. We then moved to the PC era in the early 90s. At the time, you'd spend a lot of money, and Professor Varma was saying today, he got his first Apple computer with 1 megabyte of memory. Can you imagine today 1 megabyte of memory? That wouldn't even be a good cell phone. Then first start of handhelds. Then we get today, in just the last few years, you know, we see the iPod coming out, and then we've got now the iPad, all within a few years. So in my lifetime, we've gone from the slide rule to the iPad. So where will we go in the lifetime of your career if we're starting with the iPad? I just can't imagine the things that can come next in terms of making efficiency and making connections. And I'll talk a little later about what we as a company can do with an iPad that, again, just a year ago you couldn't possibly do. So technology's changing very quickly, huge opportunity. And then last, you get the connectivity. Over 750 million users on Facebook. You've got Twitter connections. And now, actually, communication devices, if you've read, are actually a big part of what's happening in the world. The Arab Spring, driven from Tunisia to Libya to Egypt. A lot of it is driven because nations that used to be able to control communication can no longer control it because people could connect. So now technology is having a huge influence on governments and society and policy. And again, going forward, what can we do? How can we enable this? And obviously 200 million tweets per day. Even my business is caught out with how do we use Twitter? How do we use Facebook? How do we bring it to market? And I had a staff meeting recently, and everybody came and said, you know, we should do something about this. And I said, you're right, we should, but the only way we can do something about it is I have to fire all of you and hire a bunch of people 24 and 25 years old, because they're the only ones that are going to tell us the secret to how to use this. And I know I'm right. My team won't get us there, but the rest of you in the room who know how to use this will get us there. Go to the next slide. The other thing that's happening is information. 40 exabytes of information were created in this last year alone. Did you know that that's more information that was created in the last 5,000 years? So in 1 year now, we can create the previous 5,000 years. So again, technology has enabled us through sensing, through better data gathering, through better automation, through all this to have access to all this information. But having information is actually of pretty limited use. In some cases, you can do something with it. But most important is how you use the information, how you get the information in the right form, the right place, into the right hands of the right person, so that they can then go make something from it, change something, improve something, optimize something. This is actually something quite at the prominence of my company, because for us, we spent the last 30, 40 years gathering information from process plants and trying to make sure they ran properly. Well, now we've got to the point where the control, the sensing can bring us the information, but what do we do with it? How do we make things more efficient? How do we make things safer? How do we make things greener? How do we make things run with less intervention or with less qualified operators? Well, it's up to all of you in the room. It's all of you that will find out how to take all this information we're gathering, build tools, build software, build solutions that can now take this, put it in a usable format so we can make a better world. So we've got, one hand, technology changing quickly, the enabling fact that we've got a lot more information, but who's going to put it together? Engineers and scientists are the only ones going to put it together. Another trend, that is, there's several mega trends going on in the world. Recently, there's been some books written. In fact, Thomas Friedman has written about, he was born in the same year I was born, 1953. If we live to lucky enough and exercise enough and don't travel too much and get to be 100 years old, in 2053, the population will be 3 times bigger in the world than when we were born. In fact, just in the next years of our life, there'll be several more billion people born in the world. Think about how many barrels a day of oil, or how much thousands of cubic foot of gas we use today to keep the planet lit and moving and traveling. Now take the fact that we're going to add 2 to 3 billion more people in the next 30 years. How are we going to manage that? We have a huge energy challenge. Just take this billion people. Let's keep it simple. We'll forget the 3 for now, just a billion. If you give all billion people a light bulb, it would weigh about 20,000 tons, about 15,000 Priuses. If they go to turn on that light bulb for just, let's say, 4 hours a day, everybody of the new billion gets one light bulb for 4 hours a day. That takes 25 500 megawatt power plants to give enough power for one light bulb for those 1 billion people for 4 hours. Imagine if those are coal-fired power plants, because think about it, most of those billion people are going to come in parts of the world where today power is generated from coal. Imagine the emissions we'll have from the coal that we have to deal with, besides getting them energy. And how many of those people are going to be satisfied with one light bulb for 4 hours a day? They all want an iPod and an iPad and a flat-screen television. Now add up the energy. So we're going to face a huge issue going forward with energy, with water, huge challenge of water, the need for conservation. We have a huge challenge with our environment, how to get green at the same time, feed and grow these billion people. We have problems, obviously, with food chain and health in the other environment. So this gives you a view of the challenge to get all those megawatts of electricity and what we have going forward. So we've got challenges, we've got all this data, and we've got all this new technology coming in. So some people sit down and say, and in fact when you read the newspapers today, they say, oh my God, I've got all these problems. What are we going to do? We're running out of oil. The oil's in places that governments we don't like. Governments are in strife. We have environmental problems. When I was growing up, my grandmother said to me, she said, people will always talk about problems. People will bring you problems. People probably bring you problems today. But what she said to me is, don't look at them as problems. Look at them as challenges. Use the word challenges, not problem. And when you use the word challenge, then you can link it with the word opportunity. So yes, we have things that people call problems, but we also have huge opportunity to solve those problems. And again, who's going to do that? Those of you sitting in the room. You're the ones that put together the technology, the challenge, bring together the new solutions. See if I can get this slide to move on here. So I'm actually optimistic about the future as long as we have enough engineers and enough scientists to get us there. So let me go back now, face of those challenges, and tell you a little about my career, where I've been, how it's evolved, and how some of the, in my lifetime, solutions have come about. There's my class picture. I'm glad it's really, really blurry. Nobody can pick me out there. But my career obviously started after being a co-op here at Purdue. I went out for job interviews. I had about 6 different companies. Because I was a co-op in the polymer rubber industry, all of the rubber polymer companies wanted to hire me because they wanted to learn the secrets that I was doing at Firestone. I had several other offers from oil companies, DuPont, and I had an offer from UOP. And I know this sounds a bit strange for someone who had a massive amount of debt. I actually chose my lowest offer. UOP actually offered me the lowest amount of money of all 6 job offers I got. And I talked with people, some professors and others, should I do it? At the end of the day, everybody said, do where you feel most motivated, where your passion is, where your interest is. And UOP actually offered me a career where I went to Chicago for a year to work in the pilot plants, and then they said after that, you get to see the world. A year in the pilot plants, and then we send you all over the world for as long as you want. And I said, you know, that sounds pretty interesting. I said, I'll take that even though it's the lowest pay, and let me go out and see the world. So I chose UOP over all the others, and my career went from there. So one of the places I ended up, soon after the pilot plants, I was actually there only for about 8 months. They then sent me to Mexico, Brazil, Japan, several places in the U.S. And then I ended up, after about my third year in Port Arthur, Texas, where they put me in charge, actually in charge of the startup of a $1 billion catalytic reformer, the largest in the world, making 40,000 barrels a day of high-octane gasoline. It was the largest catalytic reformer ever built at the time. It was continuous regeneration, all this good stuff. And they appointed me crew chief at 26 years old for somebody's $1 billion investment. So I went down to Port Arthur, and we basically had to go in, inspect. It turns out we had to rebuild the entire reactor internals, get the reactor loaded, started up, operated. I spent about a year and a half in Port Arthur doing that. Obviously learned a lot of Texas speak and a lot of Texas cuisine. And but it was obviously a great assignment to be given that responsibility at 26 years old. Then UOP came to me and they said, well, we've got another job for you. And this time, for the first time, they said, you have a choice. And they said, you're going to like one and you're not going to like the other, but we thought we'd give you a choice. So I said, well, tell me the one I'm going to like. And they said, well, you can go just down the road to Lake Charles, Louisiana, and start up another one of these CCR platformers, not too far away, pack up your car. I said, well, what's the one I won't choose? They said, well, your other one, you can go to Siberia. I said, well, again, I followed my passion. I said, okay, I'll take Siberia. They said, really? The last 5 guys we've asked that have all said no. I said, no, I said, I'm a little tired of South Texas. I said, a little tired of the cooking. I said, I need to cool off a bit. It'd been a hot summer. I'll go to Siberia. Now, they did tell me it would only be 3 to 6 months. It turned out it was much longer. So let's see where I went. So I actually went to a city called Ufa, which is the capital of the Republic of Bashkortostan, which is in central Russia in the Ural Mountains. There's actually a little picture of it over there. It's actually, most of you probably don't know, it's a city of 1 million people, but it has the refining capacity of Italy. It has 4 refineries, 8 petrochemical plants, all in one city. It's not the most environmentally clean city in the world, I will say. So here I am in 1981, when it was the Soviet Union, the evil empire, all sanctions by U.S. government, being the first American probably ever sent to the town of Ufa. So I show up there with some French and Italian contractors to now start up an entire aromatics complex, which was 17 processes. I was the first one in. It was a crew to grow to 30. I was put in charge of all 30. So now I get some real experience. Now, the interesting thing they also didn't tell me about Ufa is that, and we'll get into this later a little bit, is that there are no faxes, there were no cell phones, there are no PCs. It takes a week to get a telex out, and if you want a phone call, you have to book it 2 weeks in advance, and you get 5 minutes, and if you're really good, you get 10 minutes. That's it. So talk about cut off, and now you're totally on your own. You can't call Chicago and say, this isn't working. You're now going to figure it out. So it turned out I was there for 2 years, starting up this complex. It took a while for them to build it correctly and get it started up. I could tell you many stories from my time in UFA. Probably the one that's most famous, I've told a little before, but for some of you, say it again. One of the biggest challenges we had in UFA was obviously relating to the Soviet system versus a Western or contract system. Well, as we're getting ready to start up the first part of the complex, the CCR platformer, the team there had sent a telex to Moscow saying, we're starting up on December 25th, 1982. Now, I think they chose Christmas Day because they thought it would make us feel good to be starting up all day instead of celebrating. On December 24th, we were inspecting the reactors prior to loading the catalyst, and the very top reactor, which, by the way, in this technology, the reactors are stacked. There's 4 of them. By the way, that was a problem, too, because the general director of the refinery, whenever we talked about the reactors, would say to me in Russian, Mr. Gilsdorf, do you know how many reactors in the reactor platformer? And I'd say, Da, Shatiri, which is 4 reactors. He said, you're correct. Let's have 4 bottles of vodka before we begin the meeting. So, by the way, later on in my career with UOP, I've spent a lot of money trying to design a 1-reactor reformer, and if any of you can do that, I will certainly support you in it because it would have saved some of my liver. So needless to say, the top reactor, which was the smallest reactor, by the way, it was minus 40 degrees, December 24th. The reactor at the bottom was damaged from drying out and needed to be repaired because if we loaded it, the catalyst would run out within a few days and we'd have a huge mess. So I went to the Russian team. I said, we have to fix the reactor. They said, you don't understand. We sent the telex. Moscow knows we're starting up tomorrow. I said, you don't understand. We don't start up a unit that isn't properly built. This is what's going to happen. They said, we don't care. If we have to spend the rest of the winter digging that's fine. We'd start up when we start up. So I took a little bit of a gamble. I went up to this top reactor. It has a small annulus. I went down into the reactor to the bottom. I was one of the Russians, luckily were much bigger than me, and I was able to get in. Only a few of them could. And I chained myself to the bottom of the reactor. And I said to them, you have 2 options. You either come in and fix it with me, I'll help you, or load the catalyst and start up. Your choice. Simple choice. You either kill me and load the catalyst or we fix it. So that took them about 5 hours to deal with that question. Meanwhile, I'm freezing a bit. Luckily, one thing they didn't figure out is they had left me 2 big lamps that were keeping me warm enough from freezing. Eventually, they came to the conclusion, which I knew they would, because I kind of had logic on my side, that it was worse to kill a foreigner by loading catalyst on him in the bottom of a reactor than it was to tell Moscow they weren't starting up. And I had to give them something that was worse than telling Moscow they weren't starting up. But once they had the excuse, and once they finally figured out, okay, we'll send a telex that we have a crazy foreigner chained to the bottom of the reactor, we went ahead, they came in, we fixed it, we started up about 2 days late. I was a bit cold, but we got started up. Then the Minister of Oil had to fly to UFA to find out who this crazy foreigner is that did it. But what it taught me was thinking logically, thinking about human nature, thinking about what drives and motivates people, and then with that, how could I work within that? And clearly they were restricted within their system of what decisions they could make at that time. They still struggle with making good decisions at times, but I gave them a reason to begin to do the right thing. And it was a little risky, but I kind of figured I'd be okay in the end. Many other stories from UFA could go on and on, but after this time here, I went back to Chicago, went into the engineering and services group. That's actually when I got my MBA. And after a few years there, they sent me off again around the world. This time I ended up back in London. So this is now the late to mid 80s, the first time I was in London. Again, an interesting part of my career. I was sent there because we had a marketing and studies group that analyzed refineries and came up with new process solutions. This group was all in their late 50s, early 60s, and refused to use the new tools of the time. They refused to use LP tools. They refused to use PCs. They refused to do optimization. They would do everything by hand in the old way. So they said, Norm, I know you're 25 years younger than all of them, but you go in and either they change or you change the system. So essentially I had to go in and completely redo a group, rebuild it, and now bring on people that would use the modern tools and modern techniques. So that's maybe another lesson learned on my career. You need to always be learning. You need to always be changing and adapting. Don't get stuck in the old way of doing things. One of 5 different times I was in London. I actually went back to Chicago several times and in my career, and actually then in the early 90s I was sent to Russia again. It was 1992. Yeltsin was on the tank. The same day Yeltsin was on the tank, the president called me in and said, guess what, Norm? I was running an R&D group at the time in Chicago. They said, Yeltsin's on the tank today. I said, yeah, great. Well, we want you to go to Moscow in the next week and rebuild our business there because the oil ministry that bought everything is now gone. You go find where these 47 refineries are and 40 chemical plants and you build a business. So I arrived in Moscow, just me, myself, and my suitcase, and said, how do we build a business? So I had to hire my first person, figure out how to pay them, figure out how to get going, and this was all during the 90s, where, as you know, there were a lot of good shootouts, hostage takings, lots of fun in Moscow. We built the business to $100 million within 4 years. It's been a very successful business from then. I got to learn every republic of the former Soviet Union and look at every corner of Russia. I have airplane tales that none of you would want to hear that go on and on about having to pay bribes just to get off the ground and drunk pilots and whatever. Leads me back to, at the time, I was also given the job of doing the Middle East and doing India. So I had former Soviet Union, the Middle East, and India. I said to the head of the business development marketing group, why do you give me this territory? They said, it's all north and south. It makes sense. I said, but do you realize the only people that fly north and south are Aeroflot and Air India? No, we didn't think about the airlines. I said, but look what options you give me. They're notoriously not the best airlines in the world. So I went north and south. And one of the projects I started to develop that's only come to fruition is called Shaw Gas. This is a project in the United Arab Emirates, and I wanted to bring this up even though the project was developed many years ago, but really coming to fruition today, to talk about technology and how technology is enabling change. This Shaw gas field, this is a 28% H2S gas field, one of the largest in the world. In the 1960s, the Abu Dhabians tried to develop this field. They killed thousands of people. The minute the H2S escaped, it's deadly, everybody died. 1970s, they tried to develop it again, hundreds died. 1980s, tried to do it again, we're down to dozens died. 1990s, they just said no. This field is now being developed, and it's being developed today, and so far very successfully, because of technology. because today there is wireless gas detectors that sit in a wireless network that everyone can wear wherever they are in the field. And the minute the smallest amount of H2S is shown, they're immediately shut down. The worker can wear a safety pack with him today that immediately protects him. The system can be run remotely from a remote operation station. It can be operated in a totally wireless environment with all new technology to deal with corrosion. So here's one of the biggest gas fields in the world that's been one of the most deadly gas fields in the world that's now moving to be one of the most productive in the world only because scientists and mostly engineers have developed technology around control, automation, and whatever. So it's an example moving forward. So one last example I'll use about technology. To me, this is, I go back to my Russian story where I told you about the telex, no faxes, no mobile phones. The most interesting thing when we were there is the phone calls. You sign up 2 weeks in advance. You'd say, I want to call for 5 minutes. Problem is, we had several guys on our team. One guy in particular, the instrument guy, he would get his phone call. He was an Indian, and his wife was in India. He would get the phone call, he'd get on the call, and after 30 seconds, the phone breaks. 30 seconds, the phone breaks. Got to sign up 2 weeks for the next 5 minutes. 2 weeks later, he gets 30 seconds into the call breaks. So this happens 3 times. So we're talking with him. We start arguing, complaining. The Soviets would say, not my problem, don't know, sign up again. Well, it turns out he would switch from English to Hindi 30 seconds into the call in speaking with his wife. They didn't have a Hindi translator. They had booked the English translator to listen to his call. So when he switched to Hindi, they couldn't listen. They had to break the call. So it started a new process. We had to identify what language we were going to speak for our 5-minute telephone call. So this, by the way, by now is 1984, not all that long ago. Had to have a translator 2 weeks. The marvelous part today is my wife has many friends in Ufa. Every day, practically, she can now Skype for free, live on video, with her friends, with her family, in Ufa, constantly, real time. So this is just in a little over 20 years, we've gone from this telephone call 2 weeks in advance, interpreter. Look at the walls that have been broken down. Look at the innovation that technology's come. So my challenge to all of you is how can you take all this innovation and apply it to all those problems we have? So as I look at my career, I look at my time and my history, and I look at the places I've gone in the world. And to me, this is an important reminder everywhere I've gone. And I like to refer to this Einstein quote. You know, scientists investigate which already is, engineers create which has never been. And this is why I'm optimistic about the future. I'm optimistic despite all these problems because we have all of you sitting in the room. We have all the other graduates coming out of Purdue. You have within you the tools now and the structure. You can take the innovations technology's bringing. You can grab that data that's available. You can now wrap your arms around these challenging problems. And I'm optimistic that you're going to take what some people call problems, my grandmother calls challenges, and you're going to take them into opportunities. So I think the class that you're all graduating from, it'll be on an iPad, and it really will be creating a better and a greater world for everybody. So I wish you all luck. I'm counting on all of you because I want to get to 2053, and I want to be able to manage those 2 to 3 billion people with a satisfaction. So take some questions.
Which will be first from the students. I wanted to mention that Honeywell, through Norm Gilsdorf's instigation, is one of these corporate sponsors of our Centennial. And on these banners, you see the Honeywell name there, Norm, so you can see your contribution.
Very good.
Okay.
Thanks.
And secondly, I wanted to mention that, as he said towards the end of his talk, about his wife talking with family, so Luma was his translator while for some period when he was there, and so the translation became so correct that they married, and so his wife is Luma from Ufa.
Yep.
That's why she's talking to her family. So,
Yep.
so he's international family as well, not only just working internationally, but living internationally as well. Okay, so now student questions first.
Yes.
In the beginning of your talk, you mentioned something about the rate of data that we produce each day. 1 year we produce more, 5,000. Will be a year or period that we get saturated and we can't, we just keep repeating ourselves? We have to use the data, right?
Well, yes, the answer to your question is yes. I think actually we're at saturation or beyond. I think today there's too much data. And we don't, because of that saturation and that overload, some of it's just repeat data or worthless. But we can't find the good data and get the good data in the hands of the right people. All the companies I talk to in the world, the biggest oil companies, will tell me there's less and less experts. They actually have less engineers than they had years ago, but they've got mountains of data, and their engineers are overloaded with what do we do with it. So that's where, again, companies like ours and other companies out there, and I think some of you have been looking at careers and how we can then take that data, clean it up, remove all the noise, all the garbage, get it in a point, in a position where you can begin to actually make good use of it. I can actually give you a good example of that. Shell Oil today runs all their offshore rigs in the Gulf of Mexico and Brazil through a special place in New Orleans, but they have very few engineers left today that know how to manage the whole production cycle of an offshore well. And it turns out, if you look at the data on an offshore well, you can see 5 or 6 years in advance, little teeny adjustments to data, which if you make the right move, can change how much is produced from that well tremendously. For those of you in biomedicine, the one I'm looking for, I'll give you the analogy, is I'm hoping that if you could scan me today and say, in 7 years, this is going to happen to you, and if you stopped eating this and started exercising that, you could live longer. Well, that's what we can do with oil wells today. But the only way to do it is we have to clean up that data, manage that data, and then find the right expert in Shell to put it on the desk who knows how to do that one-off thing and two-off thing to fix it. So that's going to be a huge opportunity going forward for those of you in simulation, for those of you that went into modeling, for those that went into supply chain. There's just a lot you can do today with building the right tools to help people. So I answer your question? Thank you. Yes, sir.
Looking back at your career, what would you have done differently?
You know, I would have done absolutely nothing differently. Seriously, I have been pleased that everywhere I've been, whatever I've done. I would not say I would do one thing differently. And I'll tell you the other thing, I did not manage my career. I never asked for one position that I got. They came to me every time and tapped me. I got a job, they gave me a job. My focus was to do the best I possibly could with that job, work at it the hardest, find the best parts of it, be as successful as I could. That's all I ever focused on. I never thought about the job after that. And it's just gone from there. But there was nothing along the way that I would do differently, believe it or not. I know not everybody can say that, but Part of it is I'm an optimist, I'm very flexible and adaptable. So whenever I got a new location, whenever I got a new job, I always look to find the best parts of it, and I try to focus on that. Now, there's points of time after 5 months of diarrhea in Mexico, I had some second thoughts, but the third time through the Indian emergency room for being sick in India, a few of those times I said, what was I doing? But no, I really have no regrets in any of my time.
He told me yesterday that he has a 10% discount in the most famous emergency room in the hospital in Delhi.
Yeah.
They frequently dive with invisible.
Well, there was actually a time when I went to India years ago where they actually came to the airport and wanted to put the IV thing in my arm while I still was completely with fluids, so that it would be easier to inject the bags of fluids later, but I've now learned and gotten over that. That actually, by the way, was not caused by India. That was caused by Kazakhstan, because many years ago I was at a ceremony in southern Kazakhstan with the president of Kazakhstan, and they have a famous drink there of unpasteurized raw camel's milk. But to make it more flavorful, they cut the neck of a sheep and put the raw sheep's blood in it. And then you drink it. And I had to drink it because it was the toast of the president. Now, what I didn't realize until it was too late was you were supposed to drink those 2 or 3 bottles of vodka afterwards. And I had decided not to get sick on the vodka that night, so I was managing my vodka intake, but it wasn't enough to overcome all the stuff I put in me from the camel's milk and the sheep's blood. So that caused my system to not work so well. Anyhow, I know it's before dinner time, so I won't go any further with it. Other questions? Yes, sir.
So, since, I'm sorry.
Yeah, okay.
That's okay.
No, you're there.
All right, fine. So we have all these challenges, so how are we going to motivate, the population that we have to actually go into these careers to tackle these challenges? How do we, get people who have the aptitude to actually get into engineering?
Very good question, and a very challenging question, because many people today are not taking on science and engineering the way they should, particularly in the United States. In other parts of the world, it is to a greater extent than the U.S. For some reason, and I don't quite know why, and I'll apologize to all the lawyers in the room, too many people want to become lawyers for a long time. Hopefully that's changing. And then too many people thought they could go to Wall Street and make a lot of money. We need to change kind of who the heroes are in the eyes of our young kids. We need, and I still have tried to position this at various people, I do talk to the government a fair amount, we need kind of the space race for engineers and technology. We need to make it sexy, to be honest. We gotta show what it's like. If I showed you today the Reliance Jamnagar control room, biggest refinery in the world in India, that's as good and as sexy as any Apollo space launch. In fact, it's got more computing power, more software, more sophistication than any launch to the moon ever had. And I know that well because the Honeywell computer was on the landing craft, the one that failed to reboot and the guy kept kicking it. But it really is sexier than we let on. It's much greener than we let on. A lot of people think chemical engineering, you're going to deal with pollution and pollutants and this. Yes, you deal with potential pollution, but it's actually you that prevents the pollution, make it cleaner, make it better. Making biofuels is going to be a big thing toward the future. Solar energy, all of these things. So we need to get that message age out and we need to get it younger. So corporations like ours are spending a lot more money now, meeting with high schools. We're opening contests to high schools, giving away prizes, things to show people. We're making videos of what's going on out there. We've just got to do a lot more of it a lot faster. And then obviously all of you going out and being successful and being willing to talk about it and being able to share it with whether it be younger brothers or younger schools in your neighborhood. It's the only way we're going to get out of this and get more people involved. But I think it's a cycle also. I'm hoping it's going to come back and come back strong, because if it doesn't, let's face it, these challenges are going to eat us up, because there's kind of the law of large numbers, and we've reached that point in the law of large numbers where things are going to begin to be moving faster and faster in terms of energy, the environment, and water. And we've got to now catch up to this with some solutions pretty quick. Good question. Thank you. Somebody else had a question in there? One of the questions somebody said beforehand, I'll kind of, maybe somebody's shy, is how do you know, my career has been both technical, actually sales, and eventually management. How do you make that decision? When do you make that decision? Should you make that decision? How does that work through your career? The way it happened for me, and the way I think it works well, is, you know, once you graduate and go out, some of you go into academia, which is fantastic. Some of you will go to industry. Start off your career on the technical side, and start off using the technical skills that you come out of Purdue with. I mean, that's what a lot of the companies hiring you are looking for, is leveraging that new thinking, those new thoughts and new skills. But then as that evolves, you'll begin to feel where your passion is. Some of your passion is going to be in driving for those deep technical solutions and how to evolve that. Continue following that passion. Some of you will find getting together and helping others take on new technology, buy new catalysts, get involved, and you'll start getting more of a commercial and business set. And start to judge what motivates and gives you the most passion. And you'll find over time you'll begin to evolve. With me, it was about 10 years into my career, after a lot of the travels and startups, I was still very involved in a technical job, but I began to see that, you know, I was really driven and passionate by getting out in the world, helping people solve problems by bringing them new technology, new catalysts, new automation. And my career kind of wandered from there. I don't think it's something you can predict sitting here today, exactly where you're going to want to fit. I would try it starting on the technical side, and then just follow where your passion and motivation takes you, and that'll be the best guide going forward. Other questions? Yes, sir.
You've had an amazing career. You've been all over the world. You've done all these amazing things. But how do you balance that with your home life, with your family?
Good question. I'm glad my wife's not here. She would probably help answer that. It's not easy. It's not easy at all, because tremendous amount of travel, tremendous amount of time away from home. So there's obviously, I'm sure, a lot of things I could have done better there, and a lot of things she would remind me that could have been done better. The biggest thing to balance it is communication. We communicate a lot. I love all the new tools. We're online with either a Twitter or an email, or if we can on you know, getting face to face over one of the sharing tools. We talk every day or communicate every day. She luckily travels a lot herself, and our children, one lives in the U.S., one lives in Russia actually, and we're in the middle. We take time to go with both of them, but it certainly is a challenge. You have to just work at it right from the beginning. And you need a partner. I'm very lucky, a partner who's very accepting of that, and is very patient with that. And that part I'm very fortunate and lucky with. So I thank her for that. But you're right, that's one of the big challenges, is that balancing.
One here,
Yes.
In this globalized universe we live in now, what's your advice for young people about language? Can you get around in the world okay with English? Or do you really, or should we be working harder at language?
Good question. First of all, I recommend that we do work harder at languages. I think if you learn a second language, even if it's not the language you're ultimately connected with, it gives you a skill and an ability to pick up other languages or enough of other languages to be part of their structure when you're there. That's probably, if I went back to one of my regrets, I did learn French when I was young, but I wasn't great with languages, and I didn't learn it quite young enough. I do today get around and can survive in English, and I have learned bits and pieces of, I speak probably fairly good Russian, but not that great. In other languages, I've got bits and pieces to be able to connect and socialize to a minimum degree. I like to say I speak enough to get into trouble, but not enough to get out of trouble, so I have to be careful. But I recommend to anyone that we need more emphasis on at least one second language. Doesn't have to be the right one or the wrong one. There is no right one. But the fundamentals of how you learn a language will be a skill that'll enable you to pick up enough of other languages that feel part of the global world. I would stress also, you need to go forward in this globalized flat world with a very open mind. You have to have tolerance, an open mind, and flexible thought. You have to realize and appreciate all cultures, all races, all sexes, everything contribute hugely to society. And you got to go in and be open with them and sit down and figure out how they can participate and contribute. Today I run a 14,000 person business, 110 countries. I have of that like 80 some nationalities. In fact, my leadership team has 17 people, 12 different nationalities and base languages. And so that's what you're going to face going forward. You're going to have businesses and environments where you've got to work with people in all countries and all worlds. So you don't have to speak their language, but it's good if you speak a little bit, you understand their culture, you understand what motivates them, understand what excites them, and be willing to participate as much in their part of their life and culture as yours. And if you're open to that, then you'll get along just fine. Thanks for the question.
Last one, Steve.
Your stories are very inspiring, and I hope the graduate students are inspired by the story about shaving themselves to react. But a lot of your stories emphasize your ability to work with human capital.
Yep.
You mentioned several times that helped this group retool, reorganize, refocus. Was there something that happened here that helped you learn to do that? Was it something you acquired over time? That particular skill, can you comment on how that developed?
Well, I think Purdue was a great starting point. Why was that? Three things. One was it's a very multicultural environment here. So that it's much more than it was when I was here in the 70s, but even then it was groundbreaking in terms of cultural experience. Second thing I learned was we did a lot of teamwork back then. We did a lot of team projects. I felt working within those teams was hugely critical. I like to say, I'm finally admitting some truths now. My final engineering design project, what I did was I chose the 5 smartest people in the class, and I said, I'll be your typist. I could touch type, which, by the way, is a very good skill. Back then, nobody else could. I'll take care of touch typing it. You guys figure it out. But actually learning how to work with different people of different skill and background. And then the last one was my co-op experience. Here I was working in the very worst part of Akron, Ohio, running a bunch of production polymer tests with guys who just barely got sober enough to get to work in the morning. But how do I motivate them? How do I get them through? So I leveraged those early experiences, and then I think when UOP takes you and you have no land, I mean, they send me to southern Mexico, down a town called Minatitlan. I looked very young back then. I show up at the refinery. I'm here to do your regeneration. They said, you're 12 years old. Show me your ID. You're not allowed in. So you very, well, how am I going to get these people to listen to me? How am I going to get them to let me control their most precious unit? And you begin to take those, build together the Purdue experience with those early work experience. So just kind of went from there.
I think with this, let us call this to a close, the formal event at least, and all you can see from his talk and the Q&A session, all the things that have made him into a very successful person. And it's very, very clear that he's going to go much further than where he is today, and we're so proud of you, Norm,
Thank you.
as a graduate of the school. So let's thank him once again.
Thank you. Thanks.